This is the screencast for section 8.2, example 4. What about the indeterminate forms infinity over infinity, or infinity times 0, or infinity minus infinity? So we don't always have to just get 0 over 0. Well, in this case, example 4, it says identify the indeterminate form and evaluate the limit using L'Hopital's rule. Support your answer graphically. Alright, so first of all, let's look at this graphically. I see that at pi over 2, the limit of secant of x over 1 plus x looks like maybe 1 somewhere in there, because I go from negative 2 to 4. So yeah, it looks like about 1. We'll see. So now I plug in pi over 2 and see what happens, and I get undefined over undefined. So possibly infinity over infinity, I'm not really sure. The problem is the denominator here has a vertical tangent at pi over 2. So tangent of x has a tangent, vertical tangent, at pi over 2. So I'm going to have to split this up and find out what happens to the limit as x approaches pi over 2 from the left versus x approaching pi over 2 from the right, to see what happens at that vertical tangent in the denominator as well as the numerator. So if I plug in pi over 2 coming in from the left, I'm looking at values less than pi over 2, so quadrant 1. In quadrant 1, secant and tangent are both going to be positive, so I'll get infinity over infinity. Now, coming in from the right, the limit as x approaches pi over 2 from the right, now you're looking at values in quadrant 2, so secant and tangent are both negative, so I get negative infinity over negative infinity. So the indeterminate form here that I am dealing with is infinity over infinity. So let's work with L'Hopital's rule and coming in towards pi over 2 from the left. So I take the derivative of the numerator, so the derivative of secant x is secant tangent, and the derivative of 1 plus tangent squared is going to be 0 plus secant squared. Now let's see if I can simplify a little bit and plug in pi over 2, and I do get 1, so my prediction is so far so good. Well, now what about as x approaches pi over 2 from the right? Well, the work is going to be the same. My end result, though, might not. So as I approach pi over 2 from the right, sine of x is still positive 1. So now I have a conclusion that I can make that may sound familiar from back in chapter 2. Since the limit as x approaches pi over 2 from the left of our function is the same as the limit as x approaches pi over 2 from the right of our function, and they're both 1, that means the limit in general as x approaches pi over 2 of our function is 1. So now try problem number 13. Says identify the indeterminate form and evaluate the limit using L'Hopital's rule. Support your answer graphically. Okay, so number 13, we're not going to start out with the graph. We're just going to work by hand without knowing. So first of all, the limit as x approaches pi of cosecant of x over 1 plus cotangent of x. Well, if I plug in pi, I get undefined over undefined. So that means I don't really have an indeterminate form yet. I have maybe vertical asymptotes both in the numerator and denominator. So I need to split this and find out what happens to the limit as x approaches pi from the left versus x approaching pi from the right. So now I can start to use L'Hopital's rule, but first let me plug in pi, and I get positive infinity over negative infinity as pi approaches, or as x approaches pi from the left. And then I get negative infinity over positive infinity as x approaches pi from the right. Alright, so let's do now L'Hopital's rule. So I'm going to take the derivative of the numerator over the derivative of the denominator. So I have some simplification to do. I cancel out a cosecant there. Now I can change everything to sines and cosines, which is what I did in the example. I just didn't show my work for that. And then that can simplify to be the limit as x approaches pi from the left of cosine of x. Now I can plug in pi, and I get negative 1. So again, the work using L'Hopital's rule for the limit as x approaches pi from the right of our function is going to be the same. It's going to end up with the limit as x approaches pi from the right of cosine of x. Well, now I just need to think about what happens as x approaches pi from the right, and it still is negative 1. So since the limit of f of x as x approaches pi from the left equals the limit as x approaches pi from the right of f of x, and they're both equal to -1. That means the limit as x approaches pi in general of our function is in fact -1. So let's check that graphically. So I put this in my calculator, and then there would be a removable discontinuity at exactly pi, so I did 3.2 instead of 3.1415, and I get -0.9, so it's very close to -1. I do believe I would get -1 as my limit there.